Now, welcome my friends. Now let's consider question under capacitor. Okay. Now we are given a diagram that we are asked to calculate the current in the circuit diagram what above. Now this is topic under capacitor. In case you want to know the topic. So now we are asked to calculate the current in the diagram what above. So now let's try to consider some two factors that we're going to need for what to solve this question here. And three factors those factors are what they are what we call the microfarad, microfarad. They're actually the terms in capacitor. Microfarad, which is equals to 10 to the power of minus 6. Why we have called next one is called nanofarad. One is 10 to the power of what? Minus what? 9. What we call picofarad. That one is what? That one is 10 to the power of what? Minus 12. Now, once you're able to memorize and understand these terms here, we are almost done with it. Okay, it means that we are going to be good. Okay, so now and also the next step is that we need to solve for the effective capacitor of what, or capacitance of what, of this arrangement. Now this is actually what series in capacitor. Which one is what is parallel in capacitor. Don't forget, don't misuse it. Okay. Now in resistance, actually is parallel. But in capacitor, this one is what is series, which one is what is parallel. Okay. And see that what they're actually what now? They're actually opposite to each other. Okay. So now in this case now, to solve for what? To solve for series here is I'm going to apply formula. Formula is what? Is C total equals to C1 plus C2. Okay, depending on what how many resistance capacitor that we are giving. So we're going to have C total equals to the first one is what? 40 microfarad plus what? 60 microfarad, which will give us what? 100 what? Microfarad. Right? Now I'm done with this one now. So now when I solve for this now, it simply means that I've converted to what? To series connection. Okay? I've converted this parallel, what's it called? This don't mistake. We call it, this one is called the series. Thank you. So they call it series, right? It means that I've converted series to what? To parallel now. And when you convert it to parallel, then it might become what? It might become series. You get what I'm saying now? So it's converted from series to what? To parallel. This is series. I normally misuse it sometimes. So this one is what is parallel. Let's put that to be parallel, okay? Now, when you solve for this now, this series, it will become what? It will become parallel like this. Okay? Which means that when you solve it now, your answer is going to be what? Going to be parallel. You're going to solve it as well as parallel. So let's try to do that now. So now, after we've solved for this one now, we got 100, right? Which means that this has changed to what? Has changed to parallel connection. Okay? It has become like this. So let's apply formula for parallel now. Now say parallel equals to C total equals to 1 over, can actually apply something very easy, like product over what? Over sum. Now I'm using this formula because I only have two capacitor. But if it is 3 capacitor, I can apply this sum over product. Which means that afterwards start using the formula, which is 1 over C total equals to 1 over C1, 1 over C2 plus 1 over C3 to depend on what amount of resistor given to you, okay? But with amount of capacitor given to you. But with it's only like 2 capacitor, you can just apply product over sum. Chicken now. Are we good now? So now the product is going to be, I'm going to multiply this 100 times what that I got here over what? The sum, over their sum. That is 100 plus what? Plus 100. And that will give us what, please? 10,000 over what? Over 200. And that will give us what? 50 what? Microfarad. Are we good now? Thank you. So the next step is to do what now? Is to try to solve for what we are asked to do. So now we are asked to solve, what are we asked to solve there? Calculate the current in the circuit diagram above, right? So now the current, in this case now, we need formula for what? Formula for charge, right? Which is the charge, quantity of charge equals to what? Capacitance times what? Times the voltage. Okay. It's from this formula that we derive this equation out. The equation for what? for capacitor in what? In series and what? And parallel. Based on this formula that is here. Okay. So now let's go now. So the first thing is that before you can get a current, we need to get what? The charge. Because basically charge is equals to current and what? Times time. Right? So mean that the charge has what? Just formula, which is for capacitors and what? And for normal what? And for his own what? His own quantity of what? Charge that pass through what? The current. Okay, this circuit. So now we are going to use this one to what? For the second one to get the current because that contain current. Okay. Do you know something now? Or when we have the charge equals to current times capacity times voltage, that's that not that the charge equals to what? Current times time. This become current time, then equals to what? Capacitor times what? Times the voltage. Are we there now? So now we're actually looking for what current, right? I'm going to equate this time, move the time out, remove the time, this cancel out. So how the current equals to what is the capacitor that we solve for? Is 50 microfarad, right? So we have 50. Now microfarad means what? It means 10 to the power of what? Minus 6. I'm going to add 50 times 10 to the power of minus 6, then times, that's the capacitor. Now what about the voltage? Let's get what the voltage now. 24 that we have here. 24 here. Right? Then over what? The time is unknown. So we don't actually need the time since we're not given time. Let it what? As it takes, okay? So I'm going to have the current equals to, now let's see what we can do now. When I multiply 2050 times 24, that will give us what? Let's check it out. 2050 times 24 should give us 1,000. Let's see how we're going to get it first. 1,200. So we have it as 1,200. Then times what? 10 to the power of minus 6 over what? Over t. So when you have to put something what? Maybe you want to put it in decimal places or whatever I want to put it, okay? Whichever way. So I'm going to have it as current equals to, you can say play around the answer. If I put it in what? In decimal place, that's what we're going to have there. We have 1,200, that will be what? 1, 2, 3. We're going to have 1.2 times 10 to the power of what? 3 times 10 to the power of what? Minus 6. Then over t. And when you add this 3 and this minus 6, that will give us what? Minus 3, right? So I'm going to have the current equals to 1.2 times 10 to the power of what? 3 plus minus 6 will give us what? Minus 3 over what? Over t. Ampere. So I will find this very interesting, right? So I want you guys to follow the page. I will answer you guys in my next video. Thank you.